Hello, friends. Welcome. Welcome to this last topic of arithmetic and the most awaited of all and very famous in all the entrance examination, whether it is MBA or any other field. Speed, time, and distance. Yes. Okay. So let's see everything about this. So first of all, the first pillar of this topic will be like basic relation between them. We also call it as proportionality along with unit conversion. Then we have second pillar as average speed. Okay. Third one is relative speed. Yeah. When two bodies are in motion. Fourth is boats and stream. And in relative speed, we'll also take care of questions based on trains. Yeah. Fourth one is boats and streams, along with that escalators. Fifth pillar is races. In that we'll have two categories: linear race, circular race. So this is the broader picture of this topic. Okay. So let's see each of them in detail. All right. Okay. Chalo. So how do we define speed first of all? Yes, did you see? It is nothing but a particular distance covered in a given time. Yeah. So speed is equal to distance upon time. The main framework, the main background is this. From this, you can derive any other thing. So speed is distance over time. Now let's try and relate them. At a time, you can relate any two parameters. So third one needs to be kept constant, isn't it? So for example, if time is constant, you can visualize also. There is no need to by heart anything. It's very logical topic. In a fixed time, if you go at a very high speed, naturally you'll be covering more distance, isn't it? And vice versa, if you go at a very slow speed, so you'll be covering less distance in that fixed time. Okay. So that is why we say speed and distance are directly proportional if time is constant, because time was anyways distance over speed. And in variation, we had studied if the ratio of the two quantities is constant, they're always directly proportional. Recall. Yes. Second thought, speed and time are inversely proportional, isn't it? Provided the distance is constant. Yeah. Speed into time is distance. So whenever the product of two quantities is constant, remember those two quantities are inversely proportional. And this is logical also. If your distance is fixed, if you go at a very high speed, you'll take less time and vice versa. Okay, cool. Now let's apply this. If speed changes in the ratio A is to B, time taken to cover the same distance. So distance is constant. So time and speed you have to relate. Inversely related, right? So it will change in the ratio B is to A. Inverse, ulta. And distance covered in the same time. Now time is constant. So you're relating speed and distance. The speed ratio A is to B. Distance ratio will be A is to B only because it is directly proportional. Isn't it? Got it? Comfortable? Generally in such kind of questions, the first big challenge is to identify what is constant out of these three. Once you have realized that, then you can easily relate the other two and build up the question further. Okay. All right. Second part is units conversion. Yes, kilometer per hour. You know very well that 1 kilometer is 1,000 meters and 1 hour is 60 minutes, and in every minute there are 60 seconds. So overall, this is the thought. And if you reduce this further, you'll get a constant number as 5 by 18. So remember like that. No need to do every time 1,000 divided by 3600. So reduced version of that is 5 by 18. So kilometer per hour to meter per second 5 by 18, and the reverse will be, yes, divide by 5 by 18 or multiply by 18 by 5. Comfortable? Now mile per hour to kilometer per hour. 1 mile is how much in terms of kilometers? Yes, it is 1.6 or 8 by 5. So 1 mile is 1.6 kilometers or 1,600 meters. Okay. All right. Yes, friends, just a sample question. So Bolt completed a 100-meter sprint. So this is distance in 9 seconds. So what is the speed? So distance upon time. So this will be meters per second. And they're asking this in kilometer per hour, right? So 100 by 9 into, yes, 18 by 5, isn't it? 1 kilometer per hour, 5 by 18 meters per second. So reverse is into 18 by 5, right? So 9 twos are and 5 twos are. So 40 meters per second. Okay. Sorry, kilometer per hour. 40 kilometer per hour. Because it was already meter per second, we converted to kilometer per hour. So answer is 40. Great. Okay. This question, friends, the speeds of a scooter, car, and a train. Scooter, car, and a train. Speeds are in the ratio 1:4:16. If all of them cover equal distances, so distance is constant, right? So ratio of time. Remember, if the distance is constant, speed and time are inversely proportional. So how do we write that? 1/1 is to 1/4 is to 1/16. And to convert fractions into integers, what do? We have studied this in ratios. Multiply by their LCM. So LCM of 4 and 16 is what? 16. So each time you multiply by a number which is easily divisible by 4 and 16. And that number is 16 only. So final ratio is 16:14, 4:1. See, here it simply got reversed because of the numbers involved. Every time it may not happen. So the correct procedure is 1/1 and then LCM multiplication. Okay. Next one. By walking at 4/5 of its usual speed, a man reaches office 10 minutes later than the usual. Yeah. So what is the usual time taken by the man to reach office? First thing to be realized, what? What is constant here? Home to office. Yes, distance is constant. So if distance is constant, how do we relate speed and time? Speed is inversely proportional to time, isn't it? So speed 1 upon speed 2 is equal to time 2 upon time 1. This is the first method which I am solving like a conventional method. Then I will tell you the shortcut. Yes. Speed 2 is 4/5 of original speed, right? Yeah. Normal time was suppose t and the new time is 10 minutes later. So t plus 10. This is minutes. S1 cancels. So 5 by 4 is equal to t plus 10 over t. Cross multiply. 5t is equal to 4t plus 40. 5t minus 40. So t is equal to 40. So normal time is 40 minutes. That is the usual time. That is what they were asking, friends. Look at method 2 now. Yes. So if we realize distance is constant, so speed and time are inversely proportional. So look at this ratio. Yeah. So old to new. So they are saying speed became 4/5. Means if old was 5, new is 4, right? Reduced, no? So old to new speed ratio is 5:4. So what will be the time taken ratio? Inversely proportional. The 4 to 5. Yes. Earlier 4 parts of time, now 5 parts of time. So gap is what? 1 part. So 1 part more, which actually is 10 minutes more. So 1 part corresponds to 10 minutes. And usual time is old time, normal time, everyday's time. So 1 part is 10 minutes. So 4 parts will be absolutely 40 minutes. This is that shortcut, straight ratio method. Got it? All right. And so next pillar is average speed. Average speed. Don't just get carried away by the word average. Okay. When does average speed come into play? Yes, when different part of journey is covered at different speeds. And if you remember the reason behind finding the average, I want to replace all the different speeds by the same speed. So check this. So the first distance, that is d1, is covered at s1, d2 is covered at some other speed s2. Yeah. Finally, the last part here, d3 is covered at some different speed, that is s3. Okay. So what's the logic? How do we find average speed? Yes, total distance upon total time. This is the main funda. Main format is total distance traveled upon total time taken. So d1 plus d2 plus d3 in this case is the total distance. How will you find time in the first case? Yes, time is distance over speed, right? So d1 upon s1. Similarly, time in the second case d2 upon s2, and in that in the third case is d3 over s3. This is how you find average speed. In this, there are two shortcuts, friends. If distance is constant, remember we had discussed in averages, distance is constant means numerator is constant, then you should use harmonic mean of all the speeds. That will be the good shortcut. And if you find that denominator, that is time, is constant, so denominator is time, right? Then we should use your favorite mean, that is arithmetic mean of all the speeds. Remember these two shortcuts, they can save some time here. Okay, suppose worst case if you don't remember anything, this is ultimate funda, total distance over total time. Okay, all right. So see this question, friends. At 7:42 a.m., Lucky gets into a bus to go to school. The bus travels at 42 km per hour and drops Lucky a short way away from the school at 7:51. Okay, started at 7:42 and reached that point at 7:51. He then walks the remaining distance at 6 km per hour, thereby reaching the school exactly at 8 a.m. What is his average speed for the journey? Average speed. So total distance upon total time. Yes. So 7:42 he started, he reached at 7:51. The speed was 6 km per hour. Walking. Earlier speed was bus car speed was 42 km per hour. And then he walked. Reached at 8 a.m. So normal method. Yeah, 7:42 to 7:51. That is 9 minutes. Distance covered in 9 minutes is speed into time. And this speed is in terms of kilometer per hour. Be very, very careful of the units, right? So in this case, the distance covered is 6.3 kilometers. Yeah, 7:51 to 8, 9 minutes. The speed was 6 km per hour. So distance is speed into time. So in this case, the time is 0.9 kilometer. So total distance traveled is 6.3 plus 0.9 divided by total time taken is 9 plus 9, 18. Solve, you'll get this. But did you realize one thing here? What? 7:42 to 7:51, a sharp observation, 9 minutes. And 7:51 to 8, again 9 minutes. Time is constant and time is in the denominator. So denominator is constant. So average speed shortcut is what? Yes, arithmetic mean. So simply the arithmetic mean of 42 and 6. So 42 plus 6, two numbers only, divide by 2, straight away 24. What a shortcut, right? So if you're keen, if you're very, very clear with the shortcut, see how much time you're saving. Correct? All right. I hope you understood. Okay, so the next thought, relative speed. So till now, friends, we focused on the motion of one body. One body was moving, so its speed, distance traveled, and time taken overall. This was the ecosystem. But now you will see that two objects are in motion. So relative speed is a concept to deal with those things only. Okay. This is a train, stationary train. Another train is crossing this train. Suppose it took t seconds to cross. So red train took t seconds to cross this blue train. Okay. Now see, blue train is moving and then red train will come from behind. Check, 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 check. Logically, do you understand? Easy to visualize. It will take more than that t seconds to cross this blue train. Of course. Similarly, if it is coming from the opposite direction, so now the crossing will happen sooner. Yes, in this case, it will take less than t seconds to cross. Why? Why all this happens? The logic is relative speed. So when two or more objects move together, the speed of one object in relation to that of the other is called as relative speed. As you saw, in this case, there are two cases, same direction and opposite direction. Let's tackle each of them individually. Yeah, so let's see the example of same direction, a famous example of the thief and the police. So when police started chasing that thief was running at a speed of 5 meters per second. Police was chasing him at a speed of 25 meters per second. Of course, it has to be higher, right? If it wants to catch that thief. And the distance initially was 100 meters. Let's visualize a scenario 1 second later. So 1 second later, what will happen, friends? Yes, thief will move ahead by 5 and the police will move ahead by 25. So now thief is at a distance 105 mark from 100 to 105, right? 5 meters more. And police from 0, it reached at 25. Now what's the gap? Yes, 80 meter, isn't it? What was the original gap? 100. The new gap is 80. So the gap reduced by 20 meters. And don't you feel this will keep happening every second? So it becomes a speed now, which we call it as relative speed. This is only relative speed, 20 meters per second, correct? Which can easily be obtained by a difference between both these speeds, 25 minus 5. So when two objects move in the same direction, relative speed between them is difference of their speeds. That is, faster body approaches the slower body by a distance which is difference of their speeds every second, every minute, whatever the time unit is. So time taken to meet in this case will be the separation, which was 100 earlier, and the relative speed 20 meters per second. So in 5 seconds, thief will be caught. Suppose if thief was not moving only, then it will be the speed of the car only, right? Speed of the police only. So 100 divided by 25, in that case, it will take 4 seconds. But because thief is also moving, the logic became the logic of relative speed. Yeah, this is relative speed in case of same direction. All right, difference of the speed. Same direction, subtract. S yaad rakho. Same direction, subtract. Let's take the next case, opposite direction. Girlfriend and boyfriend meeting after so many years. Yes. Suppose when they started, the gap between them was 100 meter. Girlfriend is moving at a speed of 3 meters per second, but the boyfriend is moving at a speed of 7 meters per second, more desperate to meet. Yes. So after 1 second, let's visualize what's the gap between them. So girlfriend has moved 3 units inside, so she's at 97 mark now, and obviously boyfriend has moved 7 in that time. So boyfriend is at a mark of 7. So gap between 7 and 97, yes, is 90 meters now. Initially the gap was 100, now the gap is 90. So gap reduced by 10 meters in 1 second, and the same logic will take place again and again. So the gap will keep getting reduced by 10 meters every second. This only becomes relative speed. So relative speed between the two objects when they move in the opposite direction is sum of both the speeds. Yes. Perfect. So in opposite direction, add, same direction, subtract. All right. Okay. So in this case, the time taken to meet was distance upon speed, but in case of speed, it will be relative speed. Distance was 100, relative speed is 10. So in 10 seconds, they both will meet. So boyfriend must have covered 70 meters, girlfriend must have covered 30 meters. So both of them together covered 100 meters. All right, cool. One more standard situation, friends, I would like to discuss with you all. Yeah, suppose there are two people who are starting from two ends of a road, A and B. The person who is starting from A, let us define his speed as SA. Similarly, for the person starting from B, let the speed be SB. Suppose they both are meeting at point C, and they took time T to meet each other. Okay. After crossing over, they did not just stop after meeting, they continued further till the time they reached at each other's end respectively. Means the person who started from A reached at B, and similarly person who started from B reached at A. Okay. So after taking this fixed time T to meet each other, if they continued further, so the person who started from B took, suppose, the time TB to reach at the point A, and the person who has started from A took time TA to reach at B. So I want to relate this SA, SB, TA and TB. Okay, let's derive it. First time I'm deriving, henceforth you will remember this as a standard result. So can you define the distance AC? Yes. So speed was SA and he took time T to reach there. So SA into T. Similarly, this distance BC is SB into T because B had traveled that much to reach at C. Speed of the B was SB and time taken was T. Yeah. Okay. Now, this distance AC was traveled by person B and he took time TB at speed SB. So time TB is equal to distance upon speed. Distance is AC, which is nothing but SA into T divided by SB. And from this, I can find T. SB into TB divided by SA. Understood this much? Yeah. Great. Similarly, on the other hand, BC was SB into T. This distance was traveled by person A after crossing over. He took time TA to cover this distance of BC at the speed of SA. So TA is BC upon SA. Yeah. And BC is nothing but SB into T divided by SA. And from this again, I can find out T, SA into TA divided by SB. Yeah. Got it till now? Okay. Next is just equating both, right? LHS is same. So RHS will also be same. All right. So let's equate both of them. Cross multiply, simplify. So we got TA upon TB as this, which is nothing but SB square upon SA square. So ultimately SA upon SB, the whole square is nothing but TB over TA, right? So finally, SA upon SB is root of TB upon TA. This is the standard formula which you should remember. Speed of A upon speed of B is equal to root of TB upon TA. What are TB and TA? Time taken to reach at other end after crossover. Okay. All right. Okay, friends, one more thought. In the first meeting, when two people start from opposite ends, they are coming towards each other on this linear track. So suppose they met at C. Yeah, total distance was D. So AC was the distance covered by this person and BC was the distance covered by the other person. So DA plus DB is total D. So in the first meeting, both of them together cover the full track. Yes, full track length. In second meeting, yeah, suppose C was the first meeting spot. After this, they continued further. Yeah, they continued further. And if you just track the trajectories, suppose they met at E, for example. Okay. So in second meeting, what is happening? Distance covered by A plus distance covered by B is 2D, isn't it? From this first meeting point, A continued further till B and then he returned till the second meeting point. And then B continued from first meeting point till A and then he returned till this point, second meeting point. So if you see the dotted line is drawn twice now. So total distance traveled by both of them is 2D now, isn't it? CA plus BE. And this is CA plus AE. So CB plus BE distance covered by A and CA plus AE distance covered by B. Okay. So ultimately you can check AB plus AB, 2AB. So total distance is 2D. Henceforth, after the second meeting point, for third meeting, fourth meeting, and so on, every time the distance to be traveled by distance which will be traveled by both of them together will be 2D only, friends. Okay. So in first meeting, distance traveled by both of them was D. In second meeting, it was 2D. In third meeting, fourth meeting, and so on, it will be 2D only. Now till first meeting it was D. Till second meeting it was D plus 2D. So 3D. Till third meeting 3D plus 2D, so 5D. Till fourth meeting 5D plus 2D, so 7D, and so on. This becomes an AP. Its common difference 2D. So just remember this also, friends. All right. Okay. So let's apply whatever we have studied in relative speed in case of trains. Okay. The main thing to be understood in case of trains is, friends, what is the distance to be traveled by a particular train to cross another object which may be of two types? Let's see in this case. So first one, time taken for a train to cross a stationary object. Stationary object means other object is not moving. So in case of speed, it will be the speed of the train only. Other object of negligible width, for example, a man, a pole, or a tree. So their width is negligible as compared to length of the train. So let's first visualize. So time is this only distance covered upon speed. So train reached here. The moment train reached here, that is its engine just touched there. Then the timer will start, and timer stopped when its last end of the last compartment was there. So in this situation, did you see what happened? Yes. Distance to be covered was nothing but the length of the train. And speed will be nothing but speed of the train because other object is not moving. This is a simple standard situation. I hope you understood. Okay. Second case, LT over ST, the notations. Time taken to cross, still it is stationary only, but substantial width. For example, platform or a bridge. Formula is same only. In speed, it will be speed of the train only, but in distance, just see what had happened. Timer starts. Timer will not stop now. Now it will stop, right? Did you see? In this case, the distance to be traveled by the train is what? The width of the other object plus its own length. Yes? Perfect. And speed will be speed of the train only. So width of the other object plus length of the train, that is both the lengths to be added, divided by speed of the train, because only the train is moving, other object is still stationary. So in the earlier case, when other object is of negligible width, you can simply consider this value as 0. Yeah, so ultimately this is the permanent formula. Okay. And when the other object is also stationary, in case of speed, it will be relative speed, isn't it? That will be the only change. When other object is also moving, friends, then depending upon the direction in which it is moving, either the same or the opposite, we will subtract or add respectively, isn't it? But the main funda to be understood was what is the distance part. I hope you understood. If it is negligible, it will be length of the train only. And if it is substantial, it will be length of that object plus length of the train. And in case of speed, it will be speed of the train only if other object is not moving. If other object is moving, it will be relative speed. Simple, isn't it? All right. Now, next concept is boats and streams. So till now, what did we study? First, we studied proportionality. That is, we understood how to relate speed, distance, and time, keeping one thing at a constant, directly, inversely, all those things. Then we studied units conversion, kilometer per hour, meter per second, miles per hour, all those things. Then we saw what? Average speed, total distance upon total time, and two shortcuts. If distance is constant, harmonic mean. If time is constant, arithmetic mean. After that, we studied relative speed, two objects in motion, same direction, subtract, opposite direction, add. Yeah, then we applied that knowledge into trains. Mainly the distance part was to be understood. Okay, what is the distance to be traveled by the train to cross the other object? Okay, sorted, comfortable, keep these things in mind properly, and then we'll approach the questions. Boats and streams, very easy, old concept. First, let us define some variables. Suppose the speed of the stream is V, or you can also define it as W, speed of water. Stream is nothing but water only. And speed of the boat is A. And speed of the boat means its original speed, means in still water, when water is not moving. At that time, whatever the speed of the boat is, that will be the speed of the boat originally. I can write it as B. Okay. B means speed of the boat, W means speed of the water. Fix up the variables as per your convenience and remember it. Don't mix up. Keep that as fixed always. So there are two situations in this case. First is downstream. Downstream means with the stream. Of course, when boat moves along with the stream, its overall speed will increase, isn't it? Because boat is constantly pushed by the water. So speed of the boat in downstream situation, SD, is speed of the boat plus speed of the water. Okay. Yes. And second situation is against the stream, upstream. Yeah. So upstream means against the stream. And of course, in this case, speed of the boat will reduce, isn't it? So it will be original speed of the boat minus the water speed if the boat is moving ahead. So boat has to have a higher speed, isn't it? So speed of the boat only, but in upstream situation, this SD is speed of the boat only. But in downstream situation, SU is speed of the boat only, but in upstream situation, because water is also moving and the direction matters. This along with the stream or opposite. In this case, boat minus water. This much, if you understand, it's enough to solve questions based on boats and streams. All right. Okay, cool. Now, one more thing, we can apply this in today's modern world. We have seen escalators, isn't it? A moving staircase. Suppose some escalator is moving up. Yeah. And you are also moving simultaneously, but along with the escalator. So don't you feel this will be downstream situation, that is with the escalator, with the stream. So your speed will be higher, you know. And here generally we'll talk about speed in distance in terms of steps taken per second. Suppose you took 3 steps per second. In the same time, escalator took 1 step per second. So overall, you moved 4 steps every second. Yes, when you were moving along with the escalator. Yeah. Second situation, when you are moving against the escalator, of course, your speed will reduce, right? See this. So this is upstream situation, right? Against the escalator. So you were moving 3 steps per second. Escalator was moving 1 step per second. So effectively, you moved ahead by 2 steps only per second. 3 - 1. Simple. Okay. All right. All right, friends. Next thought to be understood is races. Next situation in our episode is races. Two types, linear and circular. Okay. Now, linear race. Yeah, linear race. Before we deal with any kind of question, understand some terminologies. A gives B a start of 10 meters. What does this mean, friends? That is, first B runs for 10 meters, and once 10 meters done, then A will start. So A has to move the entire track length, and B has to move entire length minus 10, isn't it? He got a head start of 10 meters. This is the meaning. Similarly, if they say A gives B a start of 10 seconds, so this is in terms of time. So first B will run for 10 seconds, and the moment 10 seconds is done, then A will start. Okay, great. Now this is in terms of starting point. Now in terms of ending point, if they say A beats B by 10 meters, what does this mean? So the moment A reached the finishing point, in the same time, B was 10 meters behind. So B has to run for 10 meters more to reach the finishing point. Okay. Super. Now in terms of time, A beats B by 10 seconds. Simple. So when A reached the finishing point, B will still take another 10 seconds to reach the finishing point. All these values are given with reference to B, the loser. Okay. Dead heat race. Dead heat race means all are equally efficient. So basically it's a tie. All finished together. They both finished together here. So both are winners. Let's be positive. Both are winners, right? Nobody's loser. So these are some basic terminologies which you should know about linear races. Also, friends, you should realize one more thing, that in this entire context of running, the moment the race starts and the moment the race ends, in this overall situation, you know what is constant? You might feel track length and all those things. No, logically, the time taken is constant. Yes. So when the race starts, and from that situation till the race ends, the time is fixed. The one who reaches first is winner, and the one who couldn't reach is the loser. Okay. Time is constant. Great. Let's go ahead and see the circular races, circular motion. Yeah. First case, let's say all are running in the same direction. So two runners, A and B. Look at it. Race started. A is the slower one and B is the faster one. First famous question. When will A and B meet for the first time? Look at this. They met here. So when did this happen? How did this happen? This is the main condition, friends. The faster runner has to take a lead of 1 lap over the slower runner. Then only the meeting will happen, isn't it? Yeah. So in the first meeting, the faster one has to gain 1 round or take a lead of 1 lap over the slower one, exactly 1 lap lead. Then the meeting takes place. So just understanding the distance, logically we have calculated this point. This is 1/4, like 0.25, and the B has completed 1 plus 0.25, so 1.25. Okay. All right. So the lead is exactly 1 lap. Now suppose race continues further. This is as good as new races starting from here. Okay. Their individual speeds are not changing. Of course, that is a standard assumption. Check now. I'm sure you must have visualized where they will meet. 1/4 circle from that first point. Yes. So in second meeting, the slower one covered 0.5 laps and the faster one covered 2.5 laps. So a lead of total 2 laps till second meeting. Every meeting, the lead has to be 1 lap. Okay, that is a basic fundamental, the most important part. Yes, this one. So till second meeting, the lead is overall 2 laps. Now third meeting, similarly it will take place. You know where? Great. Check. Yes. So this is that third meeting. So overall, these are the values. Overall lead is 3 laps. Fourth meeting. Can you guess it? Yes, I know you have guessed it right. Fourth meeting will happen now at starting point. Yes. So now the lead is overall 4 laps. So if you just see these values, you'll see that the ratio of the speeds maintained was 1:5. And the difference between these two numbers is 4. So overall, they meet at 4 points on the circumference for sure, because once they meet here, after this same set of points will repeat, isn't it? Logically, it will be same as the original starting point, original race started. So same way, these 4 points will only keep repeating. So they meet at 4 points on the circumference, and every fourth meeting will happen at the starting point. Yes. Okay. All right. I hope you understood. So here actually, logically, there are 3 questions. When will they meet for the first time? How many points will they keep meeting at? And when will they meet for the first time at starting point? But first, understand these basic fundamental concepts. Let's check about opposite direction. See this. When will they meet for the first time? Yes. Suppose they met here. What is the funda in this case? Very important. And I hope you could see this visually easily. Some part was covered by the slower runner and the remaining part was covered by the faster runner. So how can we say this? They both together complete 1 lap. They both together complete 1 lap. Yes, perfect. Don't worry about these values. This is adjusted as per those distances. Okay. So now race continues further. So one more 0.17 and one more 0.83. Yes. So basically second meeting happened here. Then they continue further. I'm sure you must have guessed it by now. Where will they meet? So third meeting happened here, exactly opposite the original starting point. Yes. Check. This is the fourth meeting. Yeah. Continue further. So now they are going to meet fifth time. Yes. Finally, I'm sure. Where will the sixth meeting happen? Great. Superb guess. Good judgment. Sixth meeting will happen at the starting point. Awesome. Again, here ratio was same, only 1:5. So sixth meeting happened at starting point and they will keep meeting at perfect 6 points. Now you have to add opposite direction. So add same direction, so subtract. 5 minus 1, 4 was for same direction. 5 plus 1, 6 is for opposite direction. So they will keep meeting at 6 points and the sixth meeting will happen at the starting point. So every sixth meeting will happen at the starting point. I hope this situation is also very clear now, friends. The golden line in red color was this only. Okay. All right. So let's summarize whatever we studied. So in circular race, if the ratio of the speed of the two runners in the reduced form, very important, in the reduced form, right, is A is to B, suppose A is more than B. So while running in the same direction infinitely, they will meet at A minus B points, isn't it difference? And A minus Bth meeting will happen at the starting point. And while running in the opposite direction infinitely, yes, they will meet at some A plus B points, and every A plus Bth meeting will happen at the starting point. Got it? Okay. So same direction, opposite direction, both together simultaneously. I'm showing you. Yes. So time for the first meeting is the circumference. The distance to be covered is circumference. Here the lead is 1 lap. Here together they cover 1 lap upon relative speed because both are in motion, isn't it? Same direction, subtract, opposite direction, add. Perfect. Based on this, you can find all other things comfortably. Yes? Okay. All right, friends. I'm sure you understood all the individual components, all the small topics of this overall big topic, speed, time, and distance. Yes. First was proportionality. Second was unit conversion. Third was average speed. Fourth was relative speed. Fifth was applying in the trains. Sixth was boats and streams and escalators. And then races, linear and circular. Okay. Keep this much bare minimum in your mind. Then we are good to go to solve the problems. So thank you so much for attending this, for giving your precious time in listening to this. Okay, I'm sure you have noted down everything. See you in class. We will rock there. Thank you so much. Take care. Bye bye.